Welcome back, chemistry fans. Today we are going to work on warm up this is day 44. This is going to be representative of what we learned last time in topic 1 of unit 9. This is all about your states of matter. So let's get into the screen and let's see what we can do to solve these. All right. So one of the first things we learned are the intermolecular forces. There were 3 particular intermolecular forces that we want to talk about. These are the forces that go in between molecules. So we're not talking about bonding, we're talking about magnetic attraction between a positive and a negative. How strong is that depends on what type you are. So if you're unsure, there are 3 types, and the weakest of these is dispersion. Dispersion is just the movement of electrons. In other words, as they move from one side to the other, if you have the electron on one side, that means you have a negative charge. If you don't have it on that side, it will be the other side that has a positive charge. That creates a magnetic attraction for another molecule to come into it. So the first and the weakest is called dispersion. Every molecule has a dispersion force. The second is a weird name, dipole-dipole. Why they name it twice, I can't quite answer, but it has to do with shape and size. So that sounds like polarity. That's what we dealt with polarity. So if we have a bent or we have a trigonal pyramid, that means a shape that looks like this or a shape that looks like this, then what we have is an unequal symmetry, and we will find that the electrons tend to pool on one side and not on the other, creating a polar region, a dipole, and those dipoles are what create these attractive forces. So now size could also be a factor. Whenever you are larger, you attract the electrons for longer, you hold them longer than you do if you are smaller. So that means either of these, size or shape, could create dipole-dipole moments, and they are more permanent because they are based on what your size or shape doesn't change, is. The final and the most important one is the hydrogen bonds, and they occur only between 3 elements, H, O, and F. So it's the exact same as a dipole-dipole, but it has to be, NOF, not HOF. It has to be between these 3 elements, nitrogen, oxygen, and fluorine, and then one of those 3 has to bond to a hydrogen. If they do, there is such a strong electronegative bond between, attractive force between the hydrogen and one of those other 3 elements, which have the highest electronegativity, that you are going to see stronger attractive forces. All right, what causes higher boiling points? Well, it's high intermolecular forces. So if you have a high intermolecular force, you are preventing the atom, the molecule from spreading. So if you can't have an atom or a molecule that gets away from its counterpart, then the intermolecular forces are going to hold together and make sure that they don't get further apart. The further apart they are, the more likely you are going to turn into a gas. So intermolecular forces are what cause the molecules to not be able to spread apart, which prevents them from becoming a gas, which means that you have to add more energy, resulting in a higher boiling point. Kinetic molecular theory. It is several parts. It says the higher the temperature, the higher the speed, the greater the distance. Another way of thinking about that one is volume, the greater the volume on this one. And so with that then means that all of these are interrelated in the opposite. If you have a low temperature, you'll have low speed, and you will have a smaller volume and a smaller distance between the particles. All right, this is everything that I wish to share with you with our first 2 units in the, or our first 2 topics in this brand new Unit 1. So thank you very much for watching. I will talk with you again soon. Take care, bye.